All right, we are now live. Hello, everyone. Welcome to our Q&A session. My name is Ishan Acharya, and welcome to our session with Steve Mathieu on the topic of developing a commercial spaceport in Canada. Steve is the president and CEO of Maritime Launch Services and is the visionary and driving force behind the development of Canada's first spaceport, a world-class commercial space complex that will launch Canada into the global space industry from near Canso, Nova Scotia. A mechanical engineer and an award-winning former NASA contractor engineering manager, Steve is at the forefront of efforts at Maritime Launch, from working with governing bodies, securing private financing, coordinating launch vehicle integration, and selecting the best-in-class commercial firms for the design, construction, and launch operations. Steve's goal is to drive the collaboration and partnerships that will support the development of a safe and environmentally sustainable commercial space market in Canada. While his day-to-day focus is focused on developing this first commercial spaceport in Canada, he also has a passion for teaching and recognizing that kids can look up into space and see opportunities for themselves down here on the ground. I'm so grateful to have Steve joining us here today to share both his insights and expertise in this exciting growing industry that one day we might have a chance to work in, and something I definitely am super excited about. So this session will be split into two stages, and for the first, I'll pass the mic, or the virtual mic here, to Steve to present on his background and work at Maritime Launch. And after that, we'll do a Q&A block, so make sure to be throwing your questions in the chat. We'll be collecting them the whole time, and we'll ask them to Steve at the very end. So with that, I'll pass the mic to you, Steve, to take it to kick it off.
Thank you very much, Ishan. I sincerely appreciate it, and really grateful for the opportunity to be here today. It is truly a lot of fun for me to work with kids and students going back 32 years now, when my career started working at a NASA facility in New Mexico. I'm a mechanical engineer by training. I went to the University of New Mexico. I have a bachelor's of science in mechanical engineering. And it was one of those opportunities when you come out of college, you're trying to find the right place to go and the right job to take. And you're given a bunch of opportunities. And I had the fortune of being given an opportunity to work on the space shuttle program for NASA. So I was a part of a rocket factory in southern New Mexico called the White Sands Test Facility. Spent 15 years of my career down there as an engineering manager, testing propulsion systems for the space shuttle. The largest engine I've tested was a LOX hydrogen engine, of 650,000 pounds of thrust, down to a 24-pound thruster that was used initially on the Apollo and then on the space shuttle program. So a wide range of skills that I learned along the way in that career. What I also got the opportunity to do there, though, was to go out into the schools as a part of a science advisor program, being able to go into the junior highs, elementary and high schools, and work with kids, and whether it's simple machines or taking a piece of space shuttle hardware and talking about it. That was always very interesting to me, that seeing these kids light up and look up and learn about the world around them. So with this opportunity to be here today, I'm truly grateful for. As I said, I had about 15 and a half years or so with the NASA contractor industry, and then the last half of that working in more spaceport-related licensing activities. The first spaceport I worked on was Spaceport America in New Mexico as a greenfield project, working on the design and development, operational startup, licensing, the regulatory framework for it. So as you can see, I've kind of painted a fairly good career background, pieces to fit really well if you can find the right launch location. And as it happened in 2016, I was given the opportunity to do a study to try to find a launch location in North America for a commercial launch site. We've got a new industry right now. It's really ramping up since the space shuttle landing, for last launch in 2011, that left low Earth orbit to commercial. So here we are today with a commercial commercial industry headed to $1 trillion in the next 18 years, almost $400 billion a year last year. And everybody's launching from government ranges. So I had an opportunity to evaluate a number of locations. I looked at 15 different sites in North America, and it ended up finding the one that the market was most attractive to the market. So the real strength of Spaceport Nova Scotia and where we are in Canso is really multifold. One, our satellite clients, they want to launch their satellites into what are called constellations in trajectories that serve well from that location. So polar, what is called sun-synchronous orbits, which is a near polar trajectory, to inclinations up to 45 degrees. And when you're looking at that range of inclinations, that's a pretty powerful offering where everybody is going today. The constellations for low Earth orbit are looking at global broadband, near Earth imaging, and many of those kinds of opportunities that require a lot of sampling and a lot of satellites to build these constellations to execute. So the opportunity for us then is we've got a great location from that perspective. But before you can pick that site, though, you've got to make sure it's safe for the public. So first thing we did out of the gate was to evaluate the flight safety and the ground safety aspects. Is it far away from the general public enough in any context, whether it's the people that live in the region there or the people downrange where you're launching the rockets, to ensure that, number one, it's safe for everyone involved. So, having gone through that piece then, along with the need for the constellation clients, that really opened the door for us to begin. We started working we announced in March 14th, 2017, that we had selected that location out of the 14 different locations that I was looking at in my study. And since then, we had done an environmental assessment. The province requested that we go back and do a focus report for them. It's kind of new to Canada. This is a first ever. Canada is not a launching state and has this opportunity to really change the landscape in our participation in the commercial space industry. So March, of that year, we announced the selection. We started an environmental assessment. We completed a focus report. So in June of 2019, we were given the approval to go ahead. We're given a very long list of things that they need us to accomplish before we can break ground. And that's the piece that we've been working on. So if I were to paint this project for you, there's kind of 5 major components to it. One is the spaceport itself, design, development, operation, those kinds of things. One is the satellite client. The third is the launch vehicle that you're choosing. The fourth is the regulatory framework. Nobody launches anything into space without a whole lot of help. There are international treaties dating back to the 60s that Canada is signatory to. And then, of course, the financing aspects of it. And all those 5 pieces then kind of have to move along together in order to successfully bring this project forward. So where we are today is we've got this tremendous momentum in 2021. Going into 2022 with fantastic federal government support, almost complete launch vehicle development for a medium class rocket, a lot of support in finalizing all the pieces for groundbreaking. We've got engineering firms doing facility design. We've got engineering teams doing specialty support equipment design. We've opened our office in Halifax and are looking to work towards a groundbreaking here in the spring. It's easily 18 months or so of construction, 6 months of a commissioning phase, and working towards that first launch by the end of 2023. So that's the goal. We've got our first client announced at the end of last year in November. We're working closely with NanoRex. And they have opted to secure our first launch to demonstrate one of their technologies as well as do mission integration for us with some of the other satellite clients that have interests in ride sharing with us on that first launch. So working towards that over the next 24 months to reach a successful rocket launch and move forward with our industry is really where we are. Really, I just wanted to kind of introduce the backdrop of kind of what brought me here. I'm in my fourth winter in Halifax, Nova Scotia. My wife and our two daughters have come up here and making a go of this. Really invested in making this project a success. So I'm happy to really take any questions.
Perfect. Yeah, no, that's a fantastic introduction. I'm sure we'll see the questions kind of come in. But I'd like to first start and kind of have a few of my own, if I can go first, as the moderator. So,
of course,
you know, the background of first starting to work on the space shuttle program. That's, you know, you look at that and it's like, wow, like that's such an incredible place to be, and kind of working with NASA and the work that they have there. So, what was your biggest inspiration, or kind of like what drove you to say, hey, like I want to go and kind of shift gears and start my own, like, I guess if you have a personal drive or motivations to be, you know, working on this?
The opportunity to work on the spaceport in New Mexico is kind of what really interested me. You know, I had a very successful career at 16 years at that NASA facility. The space shuttle program was going fine. This is 2005, 2006 timeframe. The commercial space industry is just starting to take off. There's programs that are underway. You know, X Prize Cup was going, and they're just starting to, you know, demonstrate the commercial aspects of going into space as well. So it was just that new opportunity. I've always gravitated towards the hard projects. So once I became kind of leveled off as an engineering manager, leading these teams and doing the propulsion testing of all these systems that I was doing for NASA, the opportunity to do something new and exciting was what really drew me. And so diving in and jumping in and starting my own business as a small business owner and entrepreneur was really the thing that interested me the most. And it was as an entrepreneur and business owner that I started in the spaceport development world.
Yeah. Actually, speaking of, you kind of touched on this a little bit, but I also wanted to ask you about the biggest lessons that you've learned from working in these, you know, space shuttle programs and other launch ports that you've been a part of. And kind of like, what were the biggest takeaways that you kind of bring with you on this new endeavor here?
Well, it's really fascinating because, you know, one of my heroes is Richard Feynman, if you will, and he's a Nobel laureate in physics, and he served on the Challenger board following that accident, and he was the one that really helped me really see that rockets are hard, and you have to do it, and you have to do it right. But now, if you look at in part of his participation in the Challenger report, revealed that there were all these layers of quality assurance and excess stuff that didn't necessarily add to the safety of the space shuttle program. And now we're looking at some of the commercial clients that are out there that are taking some pretty serious risks with their vehicles and their developments and everything else. So to me, I think the biggest takeaway is finding that line down the middle, where you don't have excessive extra layers of QA stamps, if you will, that don't provide any value, but you're also not being a cowboy. Safety to the general public is paramount. You know, when you're working on the space shuttle program, now that's human space flight. I worked on missions and hardware that Chris Hadfield flew on those missions. I was honored to receive a NASA Silver Snoopy Award, which is a special astronaut award. It's a safety award, and it's that kind of piece that I bring with me. Is that, you know, paramount at the end of the day is safety is absolutely number one, but it has to be done in the right fashion. Extra layers of bureaucracy don't help. And it's that down the road piece that I really have insisted on in bringing with me here.
Yeah, for sure. I remember there was I was doing some reading on the Apollo programs, and at that time it was such a rush to get to the moon, and the way that they developed those rockets or those missions often didn't always put safety at the very forefront. And so kind of putting that as a priority now, or bringing that with you here, I think is definitely a huge priority, especially going forward. Mm-hmm. I'll put up some of the questions that I'm seeing in chat. There's a ton coming in, so I'm trying to keep up here. Here's one by James, who's saying, what do you see as the biggest roadblock to reaching the goal of a 2023 launch from the spaceport?
There's no true showstoppers at this point. We have so much support from all quarter, whether it's the province or the federal government or the satellite clients. It's actually building that team, and that's what we've really been focusing on over this last year, is getting the right skill sets in place to do that. We have a lot of work to do. There are 1,000 stakeholders easily involved in this project. And whether that's the biggest roadblock, I wouldn't say. I mentioned the 5 pieces. We've got satellite clients that are interested. We've got a launch vehicle that's well along in development. We've got a launch location that is working really well with an approved environmental assessment. We've got a fully engaged federal government that has been really supportive of what we're doing. And so that leaves the financing piece, and that piece has been that's an interesting part of a career development for an engineer. I will tell you, having to put on your pitchman hat and trying to meet with investors and explain to them in terms that they can understand what it'll take and what the benefits are and the potentials are for them. So that's probably the newest thing, or the hard that for me from a career perspective. But it's also been extremely successful here. Certainly, we had a significant raise in last year. We've got another raise we're closing on now, and so that snowball is certainly rolling. We don't feel like that's going to be holding us up either. So.
Yeah, so actually that brings me to, there's somebody else asked kind of more directly, what are the financing sources? And I would like to expand this a little bit and ask, like what's your approach when you kind of pitch this project to people? Because one of the things that I found out was, a lot of investors or government agencies, they look for, how does this spaceport or the space application affect life on Earth? Like what's the impact down here essentially? So I guess, how do you pitch that into your approach?
Well, for us, we're really a part of something that's going to be new and exciting, and I think is going to be a major piece in fighting climate change and dealing with it. For example, the near Earth imaging technology that is really out there now. Hyperspectral imaging that's looking for methane leaks and the need for rural broadband capabilities. I think there's some real solutions that we're intending to provide as a result of this project. We are building our facilities. They are new. They're not old Air Force or NASA facilities. So we do have the opportunity to use some cutting edge technology to try to be environmentally sensitive, environmentally compliant, and we've got plans for a lead equivalency for our launch control center, for example, and trying to make sure that we're doing things to be good stewards. And then where the financing sources for the project are. The initial one was that first investor that believed in the project, and a couple of $100,000. There was a whole lot of sweat equity and time and effort and meeting with investors, and it's all been private investment to date. It's an interesting model though. When you look at a launch, a customer doesn't buy the launch and pay for it on the day of launch. Payments come about 18 months or so before first launch, and that's when they start. So long before we get to that first launch, there's essentially a revenue stream that is generating income into the project. Well, that is for long lead procurements and what have you, and that move this process along. So it's a combination of equity and debt and early sales that I think are really what are putting the pieces together. We would look for opportunities to work with the government for grants and what have you, if possible, but certainly moving forward here.
Perfect. Kind of shifting gears a little bit from the business side to the more technical or the mechanical side. Archie is asking, can you comment on the current state of the Canadian launch vehicle industry? And do you think will this project accelerate Canadian-made rockets going forward?
Yeah, so this is cool, right? I mean, Canada is not a launching state. It's a big deal. There's less than a dozen on the planet that have launched things into space. Back in the 60s, there was a report called the Chapman Report that had three main themes promoted in it associated with our space program. One was to start a Canadian space agency. One was to, put some satellites into space. And it was actually a promotion for doing a launch site back then too, but to let the US do the big launches and do a small launcher in Canada. Well, that last piece about doing a small launch in Canada never took hold. So here we are today with that opportunity. I've been working with students at universities. You guys have some amazing schools that are doing sounding rockets and participating in rocket launch competitions down in New Mexico at Spaceport America, for example, and winning those things almost every year in the top 2 or 3, taking every title that you can. So there's this extreme talent across the country. Not surprisingly, there are companies here in Canada that are now starting to look at and are developing some of their own launch technology. Bashar El-Zain with Reaction Dynamics in Montreal. He came out of universities here. He's working on some very cool technology. We would be delighted. We actually have an agreement with him as his vehicle develops to bring it to our site. Yes, we are starting with mature technology. I think it's the best step forward to get us going. Having a launch vehicle that has companies that have been operating in the industry for many, many decades and have the success rate that they have helps us get things going safely first, while some of these other launch vehicles that are in development come forward. I think there is absolutely going to be true domestic launch capability from Canada.
That's so exciting to hear. I'll pick the next question here, who's from Thomas, asking what kind of commercial and scientific payloads are better suited for the locations you've picked out. And I think by this, he almost refers to the kinds of orbits that we can achieve from the Canso location.
So the communications and near Earth imaging and the science applications come with it. I guess I would point you to a recent FCC filing deadline that this past November, where there were 9 companies that submitted requests for 37,000 additional satellites to be added to their constellations. Telesat is one of those. They have, I think, 200 planned in their first one, but potentially could reach as high as almost 1,500 satellites for their constellation that is about global broadband and what they can do with that. So that's a big piece for us. From that filing, though, it was clear that most of that 37,000 satellites are looking at ranges of inclinations, inclined orbits to that 45 degrees we offer, all the way down to a polar or sun synchronous orbit, kind of a 98-degree inclination that we can reach from this launch site. That's where everybody wants to be. Everybody wants to be 1,000 kilometers high and have many satellites, or not just 1,000, but many satellites in their plane that are circling the Earth in this mesh that are communicating across to each other and down to the ground and providing that information or that communication that's necessary. So we're going to have near real-time, if not real-time, imaging for monitoring storms or climate change or boat traffic or the Internet of Things, looking at vehicles that are automated without hands-on activity, how all those things are going to be controlled. All of that's going to happen with the low Earth orbit, multiple numbers of satellites.
Yeah, that makes sense. Here's a fun one. As we talk about how unpredictable Canadian weather can be, Nick is asking, do you think the Canadian weather would pose challenges for these launches?
Well, conveniently, my colleagues in Ukraine, their vehicles have flown everywhere. They currently fly for their first stages on Antares rocket for Northrop Grumman that goes to the space station, fourth stage propulsion system for Vega for the European Space Agency. They were part of Sea Launch program and built an entire launch vehicle for that. But they've also launched from Russia, from Kazakhstan, and places like that. They're very, very robust rockets. What slows us down isn't a cold day. What slows us down is a heavy crosswind. That's the day that we wouldn't launch.
Yeah. On the coast, that's not... sorry, I missed the next question here. The next question is by Laura here. Who's, I guess, looking to join this industry at some point, and is asking what types of IT/programming skills would you find most useful in this kind of application?
The design, development, and operation of our launch control center is where we will need those skills for sure. And that command and control that is going to be put in place to launch this vehicle into space, that's communicating with the satellites and communicating with the vehicle and on the ground and as it launches off. All of that has to be built into our facility, into our launch control center. That's probably the principal place that we'll be needing that skill set.
Perfect. Here's a bit of a longer but still fun question. Fun fact that the original launch pad at Cape Canaveral were made at the Claybank brick plant near Regina. And as a National Historic Site, it's fired up once a year to make the bricks. But in general, does Canada have the right materials to make a modern launch pad using our domestic resources?
Yes, absolutely, we do. The flame trench in particular is where you're going with that discussion, and we certainly have that capability. Actually, there's a quarry, a low silica quarry, very near to the launch site itself that will work very well for the constituents that we need for the flame trench.
Perfect. I'm just scrolling down here. Simeon, if you see any, be sure to let me know. Once operational, how many full-time staff would be required at the site? In addition, how many businesses or temporary staff would be coming and going to the launch site?
So our launch tempo will reach about 8 per year. We could go up to a dozen a year easily with the production capability we have. But that's our plans at this point, is to reach eight per year. So the launch vehicle comes in assembled stages, but those stages need to be put together into a full up launch vehicle. So that's the transient crew is the staff that helps assemble the vehicle, the staff that is bringing in the satellites to integrate into the vehicle, and all that piece that fits in with our staff, the Maritime Launch Services staff that is operating the launch facility itself to conduct a particular mission. So when you're looking at the operation of a facility like that, you are going to have security. You are going to have fire services. So you can look at just that alone being 40 to 50 people full-time, 24/365. Then you've got a technical services team, general services team, environmental services team that are doing just the basic operations, maintenance of the facility before launch. So there's probably on the order of 80 to 100 people that will be full-time operating the facility, and that will ramp up for a particular launch when the vehicle and the satellites begin to arrive. So, and that happens about 6 to 8 weeks before the launch. So by the time we reach a full launch tempo of 8 per year, we will always have a vehicle in process. We will always have a vehicle, satellites in process, and it'll be a steady state team of probably 250 or so people operating at the facility.
That's quite the number. Here's kind of another question that I've seen here is kind of related. We had a panel earlier in the conference about the new frontiers in space technology, and One of the fun things that we talked about was the last year has seen tremendous growth and tremendous new technologies coming out, and the next year is going to see continuous, almost accelerated growth in that field. So James is asking, are there any upcoming developments that you're especially excited about to make launches more accessible, from cost, complexity, and he also added in if it's any policy developments, anything that you see incoming.
Oh, well, I would point you back to what Bashar is doing, for example. So one of the real tests that we have as a globe is to develop propellants that are as safe as possible and environmentally friendly as possible, and that they can still perform the functions that they need in space. Orbiting satellites in upper stages require propellant combinations that are difficult to handle and deal with. So reaction dynamics, for example, has a propellant technology combination that I would certainly classify as green. Really delighted to see that moving forward, and I'm looking forward to that technology development maturing more, and him being successful, and us folding him in. There is technology now in flyback boosters for stages that come back and launch at a facility, to be refurbished, to be used again. That is certainly something that we're looking at as well. So I think there's a lot of very cool technology at the end of the day to look forward to down the road. But understand, this isn't about, for us at this stage, it's not about trying to do something cutting edge. It's trying to do something safe and reliable. That's first and foremost for us. We've got to be cost competitive for our satellite clients. We have to be safe, and we have to be reliable. So the UPS drivers that deliver the package where in space they want it, when in space they want it, with as little fanfare as possible. That's what it's all about. And then we can look at some of the new technology developments that we may be able to fold into the facility. The real science, though, is going on in the satellites themselves. That's where the really true cutting edge stuff is happening, with hyperspectral imaging and synthetic aperture radar and a whole host of other things.
Yeah, for sure. Arthur here, I think he's referring to just general question about commercial human space flights. Is that coming out, or he's eager to get onto one of those rockets?
We're not intending human-rated spaceflight at this point from this launch location. If somebody like Blue Origin or SpaceX that is working on that vehicle technology needed a site, we would be happy to talk to them about it. But we're about cargo at this point. Recognize where we're going to as a globe too, with the lunar lander program and Artemis and the James Webb Telescope and all this very, very cool stuff that's going on in low Earth orbit, building of space stations and conducting science and the opportunities come with it. There's plenty to do in that regard. Taking on the human rating for the space flight adds another dimension for sure.
Yeah, of course. Cameron is, I guess, asking for a bit of a clarification. He was under the impression that Canada is a no-fly zone and makes it illegal to launch. This is the reason why some companies have taken to launching from weather balloons. He's asking if he's missing something, or is there something else at work here?
Well, Canada actually has orbital, suborbital launch regulations that have been in existence for several decades. The last date on the one I saw, we actually used to have a launch safety office back in the 90s. We used to do suborbital launches out of Churchill, Manitoba, from Black Brant kinds of sounding rockets, for example. So I'm not aware of a no-fly zone in that kind of context. And I do know that older launch regulation was for orbital and suborbital rockets. They are in the middle of revising that older legislation as we speak, and the regulatory framework for us to work with them on.
Perfect. And yeah, I guess I think we're at the end of the questions and chats. If there's any more, we still have about a few more minutes to get the last ones in. One thing I wanted to toss your way was, I guess, the differences between kind of working in the government space sector and the commercial space sector. seeing as you kind of dipped your feet in both. So what's been your experience, and what are the, I guess, differences that you found?
Well, the government side is certainly has a lot more bureaucracy. We're part of new space here, and we have that opportunity to really set ourselves apart. And since the shuttle landing, since NASA has somewhat ceded the globe has somewhat ceded low Earth orbit to commercial entities to do things. That's where that real opportunity is for us, I think, is to blend the best of both worlds. The commercial attitude that you can do things and we can do things quicker, faster, better, cheaper is absolutely there on the commercial side. And then, as I had said before, then you have the more full or robust requirements in a federal launch regulation, for example, that you've got to find that way to weave between those two to be effective today.
Yeah, definitely. I guess last one here came in by Cameron, who said you mentioned hyperspectral data, but just wanted clarification if you're currently using it or have plans to use that technology.
We are in the business of launching the satellites and not building the satellites. But what is really interesting is that Canada has a great deal of satellite technology development, clearly with big companies like MDA and Telesat, but also some new starters as well. Kepler in Toronto with Manometres got a number of satellites he's already put into orbit. He's building more. He's got launch plans, I think, this month, if I'm not mistaken, and more coming up. There's another engineer out of Dalhousie here in Nova Scotia, actually, Arad Garagosli, just started Galaxy Mission Systems. He's building his own CubeSats and has been funded for that development. He'll be launching with us on first launch. There's a lot of really amazing technology that is coming together within Canada, and that industry is really quite vibrant. And we're just happy to be a part of that and have the opportunity to launch some of those into low Earth orbit.
Yeah. I think this question might bring us to the end of our session here, but it's something, it's orbital mechanics related. So asking, isn't it more expensive in terms of fuel to launch up north as opposed to launching from the equator? So I guess just touching on the actual launch factors.
So the answer to that is we're going in different directions. If you're launching from Kennedy Space Center, Cape Canaveral, you're doing an equatorial launch. You're doing basically in a trajectory for geostationary orbit, for example. A geostationary orbit is for a 15, 20-ton satellite that's tens of thousands of kilometers out in space, that stays in one place relative to the Earth and revolves around it. That's not where the technology is now. The technology is we want to launch the other direction. All these satellite clients, they want to launch north and south, not east and west. And that's the difference. Absolutely true. If I were to try to launch an equatorial from Nova Scotia, my payload goes down by a factor of, almost 10 of what I can do because of the amount of propellant I have to spend to get to a geosynchronous transfer orbit. I can get there from there, but it's not cost effective. But what I can also tell you is Kennedy Space Center is into the same issue that they can't launch north and they can't launch south because they would have to fly over millions of people. And at the end of the day, you just can't do that with launch vehicles, fly over the kind of population centers that are on the coast. So we go in a direction that our clients want to, and Kennedy Space Center, of course, is reaching a different range of inclinations.
Yeah, no, for sure. That's one of my personal interests is kind of those orbital mechanics and trajectory, which was kind of the focus of my master's. So love having that clarification there. But yeah, that brings us to the end of our session. So I think we'll kind of leave it there. Steve, if you have any last parting thoughts or things you want to say before we end it off.
Yeah, I would offer just this for the students out there. get where you want to go, number one, you've got to get the sails up and you got to get out of port. Don't hold yourself back, in other words. Number two, once you're out, you're going to have to tack. You're never going to go straight to what you want to do the very first time you try. You're going to have to tack back and forth to get where you want to go as engineers and students and going into this field. So, being patient and sticking with your end item goal, recognizing you've got to tack back and forth to get there is really important. But number one, get out of port, get out there and get going.
Yeah, I love that. I think that's the perfect way to close off today. So thank you so much for your time and kind of sharing your story and these answering all of our questions. It's been incredible. And for everyone else, I think we're off to lunch for a little bit. The expo will be open, so make sure to check out the expo booths where you can talk to a bunch of student teams and organizations and see some of the work that they've been up to. But yes, thank you all for attending and take care. Thank you, Steve.
Thank you. Very much pleasure.